All right, example 1. Find the equation of the tangent line of the parabola y equals 2x squared minus 5x to the point 3, 3. All right, so what I want to do is I want to find the slope of this when x equals 3. All right, so anytime you look at a point of tangency, consider the point of tangency is x comma y. What we're going to do is we're going to create a slope formula using this definition of slope I gave you. We're going to make a slope formula and then let x equal 3. All right, so each time the point of tangency establishes what x equals, the one we care about. All right. Later on in chapter 3.7, I believe it's called implicit differentiation. That's where we get a slope in terms of x and y. We'd have to substitute both numbers in. All right, but for now we're going to get every slope in terms of x and then just substitute the x value that we care about in. So this is our f of x. So if I'm going to use this definition of slope, this is my procedure for doing it. I find this to be the most efficient way of doing it. That makes it, I guess, make more sense for most people. All right. The slope formula I'm using, just to refresh, is slope equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, that's the official formula. One thing that does bother people, I don't know why, but some people get bothered by it. Some people don't like delta x. It's a little bit, I guess, bulky to write. And it's fine if you don't like delta x, you can make it limit as some letter. I'm going to call it h approaches 0 of f of x plus h minus f of x all over h. That works too. So if you don't want to use delta x, if you want to use a different letter, I like h. Okay, so let's just go with h. All right. So again, that's the official definition of derivative, but delta x can be any letter. As long as that letter approaches 0 and that letter is right there and right there, it means the same thing. All right? And going back to what I did just a moment ago where I had to put the delta x's in parentheses, you don't have to do that with the h's, so maybe the expression looks a little bit simpler. It's worth doing. So let's consider what f of x plus h looks like. Because again, looking at this structure, we're given f of x. You can't find the equation of a tangent line if you don't have an equation to go off of. So they're going to have to tell you a function, f of x. That has to be known. So that's going to be given to you. Write it down. Also, the letter h on the bottom, that's always h on the bottom. All right? Or if you're using delta x, it would be delta x. But whatever the letter, whatever h is approaching 0, that letter goes there. Delta x approaching 0, that letter goes there. So these two things are pretty much known immediately. The only thing you don't know is what f of x plus h looks like. So if I go over here and establish what f of x plus h looks like, 2 parentheses x plus h squared minus 5 parentheses x plus h. You're always substituting multiple pieces for one piece, so make sure you put parentheses around your substitutions. Then we square the binomial. That's just a simple square the binomial deal. X squared plus 2xh plus h squared. And then we get minus 5, and then we just times x plus h. I'll do that next step. I'll just distribute it properly everything on the next step. All right, so x plus h squared is this stuff. I've still got the x plus h here. Now I distribute everything through. So f of x plus h in simplest form is 2x squared plus 4xh plus 2h squared minus 5x minus 5h. Be careful of distribution, that minus signs distribute through properly when you're doing distributive property. All right? So that's my first step in doing this problem this way. I write down what f of x is, I establish what f of x plus h is in simplest form, and then I go ahead and write this definition with these things in places of these three things. So I'm going to do the slope is equal to the limit as h approaches 0 of f of x plus h, which is all this stuff, 2x squared plus 4xh plus 2h squared minus 5x minus 5h, minus all this stuff. Now notice minus f of x. Most people mess up here because they don't minus everything. I'm going to minus 2x squared, and I'm also going to minus 5x. So it's going to be minus 2x squared, and minus 5x is plus 5x. So be careful that the signs change when you're subtracting f of x. That's what the definition tells me to do. when it looks like this, it's not as obvious as when you actually see minus parentheses 2x squared minus 5x. Minus that and minus that. So that sign becomes a positive. If f of x was 3 pieces, it'd be minus all 3 pieces. So you're just distributing a minus sign all the way through. And all that goes over h. All right? That's the step that really looks like, wow, why do I want to do it this way? This looks really like we messed this all up. All right? But what's going to happen every time with a polynomial functions are very, very polite and easy to get along with on these cases. 2x squared minus 2x squared cancel. Minus 5x plus 5x cancel. Everything that doesn't have an h on it on top is going to cancel. Okay, because every time you do f of x plus h, all the f of x pieces, 2x squared minus 5x, show up. Every single time. 100% of the time they're going to be there. So they're going to cancel. Leaving you with a bunch of h pieces that are all over h. So now, this piece and this piece and this piece and this piece all divide by an h. We make all the h's go away. One h goes away. So m equals limit, as h is approaching 0, of 4x, h disappeared. Plus 2h, one of the h's disappeared, the other one hung around. Minus 5, the h disappeared, all over 1. I don't like to put over 1, I just like to keep it as a non-fraction at that point. And once I get the h off the bottom, I can't put 0 in for h right now. Once I get the h off the bottom, now putting in 0 for h is legal. 4x has no h on it. 2h becomes 0. Minus 5 has no h on it. There's your slope formula. The slope of this equation at any value x is 4x minus 5. So if x is 0, the slope is negative 5. If x is 1, the slope is negative 1. If x is 2, the slope is 3. If x is 3, the slope is 7. Notice x is 3, right? So again, that's the power of this process. Instead of getting an answer, we're getting all the answers. Any point they give me now, I've got a slope formula for this specific problem. So last thing, it says find the equation of the tangent line. To find the equation of any line, I need to know the slope, right? And we just established the slope is x equals 3, 4 times 3, 12 minus 5 is 7, right? So the slope of the line I care about is 7. The point of tangency is 3, 3. At this point I go y equals mx plus b. 3 equals 3 times, or 7 times 3 plus b. So b is equal to negative 18. Y equals 7x minus 18. Full page on that. Alright, so it is complicated. I promise you very shortly there's going to be a quicker way to get here. Alright, but know that creating a slope formula for a function instead of just find the slope of a specific number is a much more powerful process. This does it every single time, 100% of the time. No questions asked, it'll work. Sometimes this is more challenging than others. And we're going to look at some of the problems that are more challenging on Monday, maybe Tuesday. Can't remember what day it is, but one of those days we're going to see some more challenging ones. But the idea is, though, the algebraic simplification is going to be there. That's how polynomials look pretty much every time. The only main difficulty with polynomials, you start getting higher powers, you start getting larger expansions. That's where Pascal's triangle comes into play, and you might want to refresh your memory on that. Renee, you have a question?
Where does 7 come from?
Once I knew that x equals 3, and my slope formula is right here, x equals 3, 4 times 3, 12 minus 5 is 7. So again, what we created out of this whole thing here was, here's a slope formula. So if they gave me a point of tangency, then I'm going to use that x value from the point of tangency. Let's say they give me the point 2 comma, that'd be 8 minus 10 is negative 2, right? Now x is 2, right? So the slope of the line through that point would be 8 minus 5 is 3. So again, that's what this is. That's a slope formula for this specific expression. You know the point of tangency, then you know what x is. So I know x is 2. Change x to 2. 8 minus 5 is 3. Slope is 3. X is 3 in this point of tangency. 12 minus 5 is 7. Slope is 7. So again, once you know your point of tangency, because they're going to tell you that every time. You can't find a tangent line without a point of tangency, so they're going to tell you that. whatever x is in that point is the one that matters, and that's what goes into this equation.